Right, so welcome to this Man and Machine webinar on design automation. My name is Chris England, and I'm an application engineer at Man and Machine. And I'm going to be joined by Clint Brown, who's a senior technical specialist at Daytech Solutions. He's going to be co-presenting with me, so we'll be hearing from him shortly.
Morning, everybody.
There you go. Right, so just starting up, let me get my presentation going. So just a little bit about Man and Machine. So we have over 50 locations in Europe. We're one of the largest platinum partners in Europe, Autodesk Platinum partners. We represent multiple zones, so we're well structured for international companies or international groups. We obviously provide Autodesk solutions, but we also have a lot of in-house Man and Machine products as well that we provide. So not to bore you too much on that, we'll jump into the agenda. So we're going to start off with Clint. I'm going to hand over to Clint, and he's going to present on design automation within iLogic. So just a bit on the history of iLogic, and then just some of the basics of how it's used. And then after that, we're going to look at doing iLogic the Man and Machine way. So I'm going to talk about some of the past success stories we've had with previous clients, and then also just how we run our services around iLogic and the training of iLogic and obviously other automation solutions that we provide. So without any further ado, I'm going to hand over to Clint now. So if you just give me 1 second, I'm going to give him control, and he'll take over from here. Okay.
Thank you. Oh, Chris, you might have to hang on.
Let me just get rid of this for you. Yeah.
The slides are not behaving at the moment. Do you mind just forwarding them over for me?
Yeah.
Thank you. Right, great. So thanks for joining us this morning, everybody. So very quickly, iLogic itself is billed as rules-based design, and to get started, that you don't need any programming expertise, which is great. So you see a bit of code in the background. I'll show you how simple it is in a little bit. And we can embed design intelligence directly into our digital model. So we can do things like create product configurators really simply. iLogic itself started its life as a third-party add-in. It was developed by a company called Logimetrics in Canada. And it was available as an add-in for Inventor for quite a while until Autodesk bought it in 2008. And they just put it into the product. So it's been a standard part of Inventor since 2011. And Autodesk reckon that around 70% of users have played with iLogic at some stage, which is quite interesting. Okay, but straight out of the box, part of the acquisition meant that we've got a whole load of additional functionality inside of Inventor as a direct result of that acquisition. And these things are the ability to create multi-value parameters, user forms, the ability to place iLogic components, rules-based design, so actually creating internal and external rules, internal and external triggers as well. And the last bit that's not on the slide is actually the ability to import and export XMLs of all of your parameters. I'm going to show you some of this in a second. But if you're brand new to iLogic and you're a new user who has no programming experience at all, there's a whole bunch of things you can do straight out of the box without too much knowledge. And these are the following. So multi-value parameters, user forms, and place iLogic components. And I'm going to show you some examples of this. So if we have a look at multi-value parameters, this is an Inventor model. And if you change a parameter in Inventor, as you should all know, that parameter change will update our model. This is something you learn on sort of day one of your training. But we can actually go and change these parameters. So in this instance, right-click, make multi-value, and we can now add a bunch of different parameters to a list. So in doing this, we now have multiple values that parameter can be effectively, and those parameters are now available from a drop-down. So at the moment, this is still all inside of our parameters dialog, but we can now start affecting our models quite simply just by choosing a value from that drop-down. So already we've added quite a lot of powerful design configuration to this component. Okay, so what next? Well, what about user interface forms? So if we just enable our iLogic interface, either by clicking the little plus box there or by going to View and to our user interface, we can now click on the Forms tab and we can add a form. So if I right click in that area and just go add form, I'm now in the forms interface. And you'll see on the left-hand side that all of my model parameters are available, and I'm going to drag those onto my form, and you'll see that they show on the form immediately. And we can add other things like splitters, maybe a couple more parameters below the splitter. And you'll see, for instance, I've created a parameter with a spelling mistake. So I can override the display name on the form. You'll see I'll drag a picture in here and stick at the top of the form. But have a look at length on the form now. It's now spelled correctly because I've overridden the display name. Now I'm going to just put an image onto the form, as you see over there. And I'm then going to change the visual style. So there's some themes available for our different forms. So I'm going to give it this dark style, and I'll say OK. So now I have form 1, and when I click on it, my form pops up. But obviously, we want to give things better names. So form 1 is probably not the best name for this. So we'll edit that, and we'll change its name from form 1 to box size. So I'll put in box size. And I now have a form called box size, and I can change the parameters of the box based on the form. So without writing any lines of code, I now have an iLogic form that's controlling the size of my box based on a multi-value parameter. Right, we can now go in and we can add some predefined buttons. So by default, it just says done. We're going to add OK, apply, and cancel. What this means is that I can now go and change a parameter, and rather than the model updating straight away, I can add additional parameters or change additional parameters so I can stick in a whole configuration and then hit apply. So the first one I'm going to change here is our top flange. I'll make that 25. And there's a little weld tab inside the box. I'm going to make that 50. And then I can hit apply, and this is going to send all of those changes up to the model, and the model update. Just a nice, powerful use of that form. And again, really simple. So let's take it a little bit further. Let's look at place iLogic component. This is quite an interesting use case. You may have seen this come up in the past. The idea is that you can take any model in Inventor and go place iLogic components inside of an assembly, and it'll bring in that component and it'll create a copy. And what that copy does is it takes a copy of the original, it renames it, and it breaks the link between them. And you can then create different sized components. I'll show you what it looks like. From an assembly, we can go place iLogic component. I can go and place the same component, part number 4 over here, and it'll come into my model, and it'll show me this dialog box with loads of different parameters, and that's probably a little bit confusing. So the way to do this is to actually create a form, as we did before, and on the form itself, there's a little show on place component option. We set that to true and save our file. When we go back into our assembly and we go place iLogic component, we now see the form. So I can put this in, and we'll start out by maybe creating a small tray, so something 25 millimeters tall. So set our width to 300, against to 750, and our height's going to be 25, so 20, so nice and small. And we'll hit apply, and it now changes that component out. So I've got 2 of those down, and I can repeat the process. And this time we'll create some taller ones. So those will be the sort of trays or lids. And then we will create a taller version of this component, which I'll place down over here. And again, set the width the same, like a length 750. And this time, rather than being 20, we'll make it 500 high. And we'll place down 2 of those. Okay, so what we've done is we've created copies of the original that are not linked to the original at all, but that are their own unique component. So if we were to look at what those parts look like, you'll see down the bottom left-hand side over there, part 4 down the bottom is the original file. I'm pretty sure you guys don't use SIM file names like part 1, part 2, part 3, and part 4. And then we've got part 4-01, which is the tray, and part 1-02, which is the taller component. So that is the way that has gone through and copied those parts for me. All right, but let's look at creating a rule. So a little bit of code. This is really simple. Click on the Rules tab, right-click, add a rule. Always give your rules good names because you might end up with multiples of them. You'll see that all my parameters are available, and I can create simple if statements, for instance. So I can say if the length is greater than 750, then I want you to pop up a message box. I'm just saying message box, And in the message box, I'm just saying maximum length is 750 millimeters. And then what I'm going to do is I'm actually going to correct that length. I'm going to say length equals 750 millimeters, or 750 I should say, and then end if, and that's it. Hit save. And now if I go and manipulate the form, so we're putting a length of 800, I get a message box that'll pop up and it'll say the maximum length is 750. Now you'll see the length is currently set at 800. As soon as I say OK, it corrects the length to 750. All right, so let's go back into that rule. And now we're going to have a look at using some of the standard snippets that we get on the left-hand side of this. So you'll see that I can manipulate things like my I properties. So I'm going to grab the description I property. And what I'm going to do now is I'm going to say make my description equal to the parameter for length times width times height. And all I'm doing is I'm adding in bits in blue are the parameters, and the bits in that sort of brown red color are text. So it's length and space, x space, and parameter, etc., which means that I'll get length times width times height. So run this up, and if we look at our I properties, we look at projects, you'll see 750 by 250 by 150. So I'm going to overwrite that with test just for a moment, and we'll run the rule again just to show you that it works. So we'll shoot back in, and under project, description 750, 250 by 150. So nice way of using iLogic to filter some components through. I can also add text parameters. So in this instance, I'm going to say color, and I'm going to make this a multi-value parameter. And what I'm going to do is I'm going to add in a bunch of different colors. So just paste those in, and I'm going to choose orange, and I'm going to say done. And nothing happens, and that's just because I've got a text parameter. But I can actually link those back to my part color. Again, this is just a standard snippet inside of here. So double click part color, and I can say equals. Go and find my user parameter. Color, stick that in, hit save, and magically my model becomes orange. So if I edit my form and I go and grab that user parameter for color and I drag that on, because it's a multi-value parameter, it'll display the drop-down list. So I'm going to click on that and say, right, now I can change the color and I have control over my model quite simply. So with very, very minimal coding, I've now created something pretty cool. I've got a configurable box. I can change its size and change its color without too much programming at all. So here's an example from Autodesk of something similar. We've got a length of 3,000, and I can start manipulating the size of these cubicles just based on this form. And the more space I've got, the more cubicles I'll have. So if I put in a small size like 1,500, it actually tells me the minimum is 2,000, and it goes back and corrects the size and shape of those cubicles. Okay, so here's another example. I've got a cat ladder over here, and if I put in a size that's less than 800, so I put in 500, I get a message saying minimum design height is 800, model corrected, and it fixes it for me. And again, I can go and perhaps think about something crazily large. So I know that the maximum on these is 5,000. So if I put in 6,000, again, message comes up telling me what's happening, and my model's corrected. There's a couple of other design options inside of here. So you'll see that if I set a standard height or something bespoke, so 4255 is a bespoke number, I can go and have a look at how the model is connected to the building. So I've got two options. I've either got a top mount or a side mount. So you see these little tabs on the side there. The top mount looks like this, so it would fit on the roof. And if I choose a side mount, that would be connecting to a wall. So once I'm happy with the mounting that I want to choose for this specific configuration, I can set that up, and I can then say, right, well, that's my model done. I now want to create a drawing. Now, because I've got a drawing already created in the background and I have view scaling properly, I can do things like choose how to center those messy dimensions. So I'll click center dimension, for instance. So that sorts that out. And I can then click PDF, and it'll generate a PDF of that drawing for me. Now, you can imagine if you model these every day, there's quite a lot of work involved there. And here in a few seconds, I've actually managed to open my configurator, set up the cat ladder that I want in a bespoke size specific to this design, and create a drawing in a few clicks. So we can take this a little bit further. There's a product called Configurator 360 from Autodesk. It's a cloud-based solution, and we can upload Inventor models directly to Configurator 360, and all of our iLogic rules are applied to the model and they work in the cloud. The big thing here is that this is a separate subscription. So it's not part of your product design and manufacturing collection. It does have an additional cost. But let's have a look at how it works. So here's the same cat ladder uploaded to the cloud. You'll notice that my iLogic forms come across as well. It looks the same as did in Inventor, and I can apply a size inside of here. If you were to exceed the size or come up with an error, you'd get a little red dot and a message saying you need to correct this, or we've corrected it for you, as you do in Inventor. So here I'm setting up a size, choosing my mounting types, and once I'm happy that I have the model that I'm going to be using, I can then look at some outputs. So I've got a bunch of different outputs over there, and in this instance I'm asking for a PDF drawing. So what it's doing in the background is Inventor in the cloud is actually opening that drawing for me as we did in Inventor. It's correcting my dimensions, and then it's spitting out a PDF for me. I can also go and look at different outputs like step files, SAT files, and some of the BIM formats as well. So I can get an RFA file or an IFC file out as well. In this instance, I'm asking for a quote. So maybe I've put this out on my website and I'm allowing select customers to get access to it. We can ask for a quote, and whoever's set up as the administrator or the person to receive the quotes will get an email with all of the details of that specific request for quote. So we've got the option to open the model online, download the full assembly, or go and look at the RFQ details. So here I can see this person's details and their comments. So please send me a quote for 6 of these and what they've asked for. So quite a lot of additional information in the background there. And with that, I'm going to hand over to Chris. Again, if you have any questions about any of the stuff we saw, stick them into the chat box and we'll take them at the end. Thank you.
Right, thank you, Clint. Give me a sec while I switch back over. Okay, so yeah, that was a good introduction to iLogic. So what I want to show you now is a bit more about man and machine and the way we would do iLogic, and also some of our past jobs that we have worked on. So some of the automation projects that we have done would include with some of our clients like Morelands, Storm King, bigHead, and UPS. And I'm going to focus on the first 3. So I'm going to do a bit of a case study on each one and sort of discuss, what we did there and how we helped them. But just noting that, all of them were using product design and manufacturing collection type products, and some of them with Vault, and in some cases even Cool Orange as an extension. But I'll discuss those as we go through. So the first one we're going to look at was Storm King. So Storm King is, they make these little roofs. Sorry, I'm South African, I want to call them an afdakkie, but these little lean-to roofs, and essentially it's one of those grey areas in the manufacturing market where, manufacturers actually using, manufacturing products such as Inventor need to interface with the BIM world, so connecting, to things, or outputting for products like Revit with the BIM information and all the relevant properties and parameters that go with that. Now, the big problem that Storm King faced was that they were doing all of their work in Inventor, and they didn't have anyone with the skills for using Revit for actually outputting. So what they looked at as a company was to, rather than train people up in Revit, to actually look at how they could automate the process of outputting models for BIM. So Storm King is one of the largest manufacturers of offsite prefabricated component products for the construction industry. So like I say, they're manufacturers, but they interface with construction. They used Autodesk PDMC and Vault, and they also then later on, we through this project, we plugged in Cool Orange as an integration to the Vault. Their regular regularly we're asked for Revit and BIM families for use by architects. So like I say, needing to publish to BIM as an output or for BIM as an output. But none of them had any BIM know-how. So they didn't really have a desire for the manual process. As we know in Inventor, we can go through the whole BIM publishing, but if you're doing it at the end of each job, it can be quite tedious, and especially when you're trying to add in all the correct parameters for to be properly BIM compliant, it can be quite tricky. So they preferred to look for a foolproof way to automate these products, or to automate their BIM output rather. So what we came up with as a solution for them was creation of the BIM objects driven through Vault. And we did this with a Vault lifecycle. So some of you may be familiar with Vault and its products. Maybe you use Vault Basic, which does come in the PDMC. But when we look at a Vault Workgroup and Vault Pro, we have the option for lifecycles. So what we can then do is we can start to use your lifecycles to trigger certain actions. And in this scenario, we had the life cycle going from design process, as we can see here at the bottom of the screen, design in progress, internal checks. So obviously getting checked, it might go back to design in progress or go forward into the issued for customer approval. And at the issuing for customer approval, we would have a, as we can see with the little symbol, it would then open the latest file. It would then simplify it, so doing a shrink wrap within Inventor, and it would ensure the model orientation and export settings were all correct for the BIM export. It would then go and export the geometry and all the levels of detail, and obviously adding in all the BIM compliancy, so all the information, the parameters and properties that are required for a BIM model to be BIM compliant. And then it could come back for manufacturing review. So obviously if there was client comments and whatnot, it could come back to Storm King. They could then continue with the modeling process, and then when they output it for issued for manufacturing, it would then output a BIM model again. So it would update the existing BIM models. Now, the thing here is that all of the publishing was done at the end. So all Storm King would do is work on their Inventor models, so an assembly at the end of the day, and by moving it through the Vault lifecycle, Vault in the background using Core Orange would then open up the model, publish it, and shrink wrap it, and then publish it to RFA or ADSK or IFC as required for their architectural clients. So a very successful project for us, and very helpful in that sort of area where manufacturers need to interface with the BIM world but don't necessarily have the skills or the desire to go through the effort of manually publishing BIM models. So yeah, the final product was we managed to get BIM object creation through the Inventor interface, which then, as we can see here, could open up quite easily in Revit for architects without actually even needing to open Revit at any point. So the next story we have is Moreland. So Moreland, Moreland is a manufacturer of fire escape doors, and as we know, after the Grenfell disaster, they were going to capitalize on the market of needing these fire escape doors, or fire security doors rather. And so because they were planning on growing their output within the business and needing obviously more design capacity, they decided to, rather than look at hiring more people to do the same job output, or to get higher output out of the design office, they decided they would rather look at automation as a solution. So what we did for Morelands was we started looking into how we could get them a configurator. So in this case, the configurator output was all in Inventor. So essentially, they have a model, a master model, where we applied rules to, and the master model is actually capable of controlling the full project. So what it would do is we would create a new project folder. So with each job, so within Inventor, all in the Inventor interface, we would run through the form, as Clint showed us earlier. We had a complex form for this one, and it would run through having a new project folder. So we create the folder in on your server or wherever the location required was. So it would create the new job. It would then go and create all the design documentation for that job. So this is everything from, the original proposal quote documentation. So actually even the costings and everything were in there. It would create a model, so it would create a model or multiple models. In fact, if there was more doors, so if perhaps it was a hotel or something that had multiple door requirements, we could do multiple variations of those doors. So for each model it would then put it into that project folder and attach all the design documentation with it. So full drawing packs, form fabrication. It also had the scanning barcodes linked to it. So for the fabrication department, where the automation side on the CAM, for all the cutting and all of the back-end manufacturing processes were all linked to this as well. So it outputted all of that data into a folder for that job, and then pretty much they achieved full design automation. So now, regardless of how much work they start to get, they don't need to increase the size of their design team. They can simply keep outputting with this configurator. And the last example I would like to share from our customer success stories is bigHead. Now, bigHead make bolts and, well, obviously custom bolts for the automotive industry. And although this is probably not the most glamorous of the stories that I'm going to be telling, it is a perfect example for potentially any one of you, where, bigHead a lot of these bolts could be designed with configurators. A lot of it is just parametric configuration of the same sort of product. As we know with bolts, when we look at our content center, naturally these kind of bolts wouldn't be found in your normal content center. So what they decided to do, rather than in this case having us design or create a configurator for them or do any of the configuration, they went the training route. So we did an investigation and did custom training for them. So they wanted to automate the design of their product range. They already had a capable team of designers, so experienced designers that were ready to pick up the next level, which is going to iLogic. And then we rolled out a training plan for them. So this saved them lots of days on consultancy. So rather than having us come and do it for them, we empowered their team to be able to do it themselves. So obviously any new product ranges that they wanted to add, they can then go and do themselves without having to call on more consultancy at a later stage. So also a very good option, and an important one, I think, for this webinar, knowing that we don't necessarily, we can do it for you, as well as the training option. So just on man and machine and how we do things. So just the journey that we would follow to automation. So the first step is always going to be to scope the best fit for your business. Every business is different, and like I've shown in those 3 examples, they were all completely different outputs and completely different scenarios. So it's always important to scope the best fit for your business and to sort of understand what your business needs. And that could be, investigating a few options. So it could be that we do content creation for you. So we do some of the groundwork or most of it for you. Or it could be customized training to suit your products. So we do training on your actual products, doing an iLogic example with your team. And sometimes it could even be a combination of both, where we sort of help get you to a certain point and then train your team in the process so that they're ready to take over afterwards. And then it's always also important, to choose a configurator output. So we saw from Clint there the configurator 360. In the example of the Morelands job, it was, sort of going through the Inventor interface where Inventor was driving everything. And in the Storm King example, where Bolt was actually our output. So it was doing all the configurations using a product like Cool Orange. So it's important to sort of understand what the outputs are going to be. So some of the key factors when we scope in, and maybe some things to understand before sort of approaching this whole topic, would be which team members will use the final configurator. So it's always important to understand who's going to need to use it. So obviously if it's sales, we want a high-end finish, something like Configurator 360 where it's easy to use. You can log on a web interface. You could use it on a tablet on site, or perhaps use it on your laptop while you're sitting in front of a client. It could be the engineering team. So if it's the engineering team, it's always all right to do it in Inventor. where, you know, we could have the engineering team just moving through a form or going through a form and then applying rules. And lastly, it might be someone like the customers. So we might be looking at integrating it into a website. I mean, we've all been on one of the websites, you know, these days where we can go and configure our own car, for example, or our own product. And it always adds a nice touch if we can do that. And also then what the outputs will be. So it could be things like drawings. So if we're just trying to automate our drawing process and streamline drawings for our workshop, our own manufacturing purposes, perhaps we're trying to get client drawings out, so proposal or tender drawings for the front end of the business to try and make more sales. It's always important to understand that. Maybe just bill of materials. So sometimes we deal with big models of similar products, and we just need to know lengths to cut and perhaps quantities to then either, once again, front end on the sales side, we might want to be driving sales and driving more sales, or on the back end, we might just want to be doing it for procurement purposes. It can take a lot of time to do bill of materials manually, so it can be nice to have it output in a set format with the click of a button. And then lastly, model data. What kind of model data are we looking to achieve? So would we be wanting to go to DWG outputs in the case of Storm King, where we have BIM compliant model data, things like RFA, IFAs, and ADSKs. You know, it's always important to be able to determine what model data we want. And like in Clint's demo of Configurator 360, it may be, you know, just downloading a model for yourself. So if, you know, if our models are being used in plants, perhaps we're a pump manufacturer and people are going on our website to get our pump models, that's, you know, 90% of the sale there because it's already fitting into their plant. So if the model data is available, obviously with our IP being protected, it's always handy to be able to have that out there. And then just on my little form here, some of the other outputs that, you know, you might be needing to create DXFs. So creating flat patterns of sheet metal products, you know, if we're going to be going to nesting, perhaps third-party applications that are going to do our nesting, it can be handy to automate creating flat patterns, DXFs, maybe getting surface areas. So when we talk about sheet metal, obviously it's a flat pattern as well as the surface area of that, so we know sort of what quantities we'll be looking at, and then perhaps exporting bill of materials again. So with ManaMachine, you sort of get in the complete spectrum. So what we've looked at today is using Inventor. So it all sort of starts with Inventor, where we have a model, a parametric model. We can apply iLogic ruling and these sort of things to sort of help us along and get our model to do as we require. We could add in the likes of something like Configurator 360 to sort of add in the extra interface, so uploading our models to that. And then using products like Vault, Vault Workgroup or Professional, we can then also add in the automation from things like Cool Orange, where we can integrate these sort of outputs and automate them from a Vault point of view. And then, as I mentioned, Cool Orange is a plugin to Vault where we can then add in our own default customizations. And very important to remember, the reason that you might want to come to ManaMachine is that we also have our own products that can also aid in this whole automation process. So we also have our own side of it, CustomX, ECS CAD, and Hypermill, for examples. So what would be next? It all starts with a phone call, really. Get in contact with us and you know, start the conversation about how we can automate your business or get some of your models, design criteria automated. Would start with the scope of your needs and would set out a project plan from there. So we're going to have a little show off there for the end. And just remember, from a ManaMachine point of view, we also do BIM consulting, manufacturing consulting, virtual reality, data management, and cloud platform deployment. So any of these needs within your CAD, CAM, and BIM consulting requirements, please give us a shout. Also go onto our website and check out our blogs. We have new blogs coming out every week, so do go have a look there. All right, so I just want to thank Clint for now for helping me out here, but we're going to be taking any questions. So if you guys do have any, I'm sure Clint's still here to help me answer some. And yeah, thank you all for joining.